My name's Kinnear. I worked for Sun and now work for Oracle. I work on the hotspot Java Virtual Machine, and I'm here to talk to you about Java futures with a focus on modules, but many more exciting things coming. So I wanted to start out with what were our goals for Java 9. I say were, it's coming soon. For us, it's almost out the door. To enable developer productivity, we're trying to make it easier for you to develop faster, easier to deploy. We've done language improvements, library improvements, improvements for the tooling ecosystem. We're trying to improve Java for cloud environments. So Java is the basis of most commercial clouds. We want to make sure that Java is even better for cloud environments, since we know you have a language choice. Security, reliability, throughput, horizontal scalability, which apply everywhere. Startup time, reduced memory usage, predictability. Let me give you a few highlights. There's a long list if you go and look at what's releasing with Java 9. It's a major release with lots of improvements in it, so I just wanted to go through some of the highlights. So one of the ones I'm very excited about is called JShell. It's the new Java REPL, or interactive programming tool. It allows you to do rapid prototyping or API evaluation. We also provided JShell, a shell API for code fragments or snippets of pure Java code. So go play with it, try it. My friend Robert Field designed it. He's really super. Anyway, we're real excited about it. We hope you enjoy it. Give us feedback. It was one of those that when I tried it, it's like, oh yeah, but do you do this? Yeah, but do you do this? Oh yeah, you did this. Okay, so if it's missing something, let us know. Java language improvements like milling Project Coin. APIs, there's a process API update. There's more concurrency updates. So hidden under that sort of cryptic title is the Java util concurrent flow with a publish subscribe model that Jake Wharton talked about with RxJava and reactive streams, which was an excellent talk yesterday, which got recorded if you missed it. That's sort of hidden under more concurrency updates. New var handles, or they're called variable handles. If you're familiar with method handles, this is the analogy for fields to allow you to do atomics and memory model, memory order updates without unsafe. It's a long list. I picked out a few more. Things like compact strings. We're very excited about compact strings. If the string fits, we make it smaller, which uses less memory and actually makes string access faster. Faster secure application performance, a new default garbage collector. For those of you who've been following G1 or garbage first has been an experimental garbage collector. It's now the new default. We enhanced method handles. We keep making them faster. We'll keep making them faster. Keep telling us your use cases. To improve observability and manageability, we've added a stack walking API, class loader name support, which somebody asked me for in 2006. Yes, we got that. Keep asking. We'll keep pushing. Unified JVM logging, diagnostic commands, finer-grained JIT controls with our partners, new platforms, support for updated standards, reliability, improved testing, those sorts of things you'd expect in a major release. The focus of Java 9 is modules, so that's what I want to spend a good portion of this time on, since that's new to most people. Benefits of Java 9 modules. A key benefit here is faster evolution. So if you're an API provider, if you build a library, this allows you to maintain an explicit contract of your interfaces, improve security by reducing the surface area, and more quickly evolve what now becomes your internal implementation. As an API user, it makes it easier for you to port to dependencies when they update, and easier to replace components. It simplifies deployment. We have something new called JLink, which is a Java linker. Allows you to only distribute what you need, and you only need to update what you use. So what problem were we trying to solve? You don't have to read the fine print. This is a real class path. How many of you could give me a class path hell story of your own? Yeah, okay. So we've heard from quite a few people that class path was a really nice design when it was created, and it doesn't really scale well. So how many of you had two versions of the same jar on the class path? How many of you found that out in the field with one of those pager things like, oh my God, you're ruining my weekend, right? Okay, because what? Wait, okay, sorry, anyway, we won't go there. Who has had to build tools or use tools they don't understand to build their deployment class path? Okay, who has class path scripts that were built by somebody who's left the company? You want me to maintain this? I'm never taking anything away, right? I'm just adding, because I don't know what's used. Okay. It's painful to watch it in my own company. Does it ever happen that the production class path differs slightly from the one you developed and tested? All the time, right? Oh my God, how am I going to debug that? I can't duplicate it. Sorry, I'm clearly the developer on the back end here. So some of the key questions we ask with class path are, is anything missing? You remember the example, right? So on that third line, right, what was missing there, right? Will I get a no class def found error at runtime after running for a couple of hours or weeks or months? Are there any conflicts? Do I have the same class, do I have the same package on there twice, nested in one of the other manifests? So just to be clear, everybody knows how class path searches are done. They're linearly. Let's see, left to right for you guys. So if I look for a class, so I write class loaders and things like that. So what we do when we write a class loader, when we look for a class, we scan the class path, okay, in order. We open every jar. If we don't have it cached, we walk to the index. Why did they put the index at the end? I never got that. Okay, and then we find the class and we return it and say, got it, found your class. Now we can actually read it and use it for you. So if you have old package, you have the same package name, but the old version here and the new version here, and the first class you reference comes out of the new one, okay? New package, class new, and I find it, because I'm your class loader, sorry, I identify with a JVM. Scary, isn't it? And I find the class, and I run it for you, and it references something like foo that happens to be in both. Guess where I'm going to find it? Oh, over here. Well, it's not the foo that matches this one, right? It's the first foo I found on the path. So I just wanted to be sure you understood how we look for this. So accidentally, you came up with the wrong one, and now you're not sure what's happening because the behavior's changed. Do we actually use all these jars? Do I have to do security updates on every one of these because deployment is often harder than developing code, I've been told? I don't do deployment, but I have been really amazed at how hard it is to do deployment, so my respect for that has gone way up. I do know how hard it is to code. So is it safe to change an internal API? Is somebody using it? I called it impl. I called it unsafe. I called it something that said, don't touch this, please. So we've mentioned that ClassPath doesn't scale well. Well, we decided we wanted to create a new abstraction that would help you define a related body of code. So requirements for a module system. Reliable configuration. So the first requirement is we want to be able to assemble an application out of modules where each module clearly expresses the modules it depends on. Okay, so we can statically validate the integrity of the configuration. So the presence of all required modules before we run the application, the absence of conflicts rather than finding them in the field, and we believe that we can validate and enforce this at both build time and compile time. So that's one of the benefits of our building the module system into the JRE, is we can make the same checks at compile time and at runtime. So you can get a consistent picture, and frankly, if you catch it at compile time, it saves you a whole bunch of those phone calls, right? The second big thing is strong encapsulation. So the key here, I keep drawing these little circles. That's my encapsulation circle. A module should be able to declare which of its packages it's going to export to its dependents. What is your external API versus what is just internal implementation that I need to be able to play with, that I need to be able to evolve because the world doesn't stand still. So anything that you don't explicitly export should be considered an internal implementation detail. So packages help with this, but how many of you write applications with hundreds of, or tens or hundreds of packages? Have you ever used a library that has tens or hundreds of packages? Okay, well, it doesn't scale that well, okay? Packages are a great concept, and we needed to take it one further. So if you're developing an application, strong encapsulation means you don't accidentally use internal types of the libraries. So you're more likely to keep running when you upgrade that library. And it means your library developer can deliver changes to you more quickly. And we think of ourselves as a library developer. So let me get right to the heart of the concepts for modules. The key question here is accessibility. Can I access class D? Okay, so in Java 8, we have two containers. We have a class inside a package. And when you create your class, you have two choices of access, ignoring nested classes that have more fancy choices. You can not specify the class access, and the default there gives you package access, or you can say public. Those are all the choices we gave you. So if I am in your same package and your package access, the answer is yes. If I'm not in your package, the answer is no. If it's public, the answer is yes, okay? So very easy little matrix. For Java 9, we wanted to extend that without requiring you to rewrite your source code. So we have a class which is fully contained inside a package, which is fully contained inside a module. So I drew a little picture. I'm really bad at pictures, so I apologize. Most of these slides are text. I'm a bullet person. So in the example, we have class q.d. So fully qualified name did not change with the addition of modules, okay? Your source didn't change. Your fully qualified name didn't change. So class D in package Q is now, can be in module Y, okay? So the default access, the package access, is completely unchanged. Am I in the same package, okay? Public now has a finer granularity of meaning. It can be public within the module, like package was within the package, public within the module, public to specific other modules, or public to all. So the simplest case is if you're in the same module, the answer is yes for public. But we've given you finer grain control. So where do you put that information? So there's something called a module descriptor, which is new, which is where you put your module relationship information, okay? So it's a Java source module. It's called a Java source file called moduleinfo.java. It lives at the top of your source tree for that module, or the top of your jar. It compiles into moduleinfo.class, and it declares your module metadata. So the easiest thing you put in there is a module name. This is creatively MN. When you work in the VM, all of your names of packages and classes are 1 or 2 characters, because, you know, typing sucks. You put in your requires module name. So I talked about you declare what you depend on. So my module depends on this one. My module requires this other module name. You export packages to a module name, okay? So this would have a list of modules that you export to, or if there's nothing in that list, it's export to all. We added a concept called opens, because frameworks often need to reflect on your packages. And that is, we wanted to explicitly say it is okay for a framework to reflect on my types, my public types. So let me give you that example now that you know a little bit more about modules, okay? So it's not can I access, that's because I work in the VM, I think of it that way, but can class C access public class D, right? So in Java 8, if D is public, the answer was yes? Okay, so in Java 9, we look at the module descriptors. No, you don't see my key. So if you look at the first line, the blue across the top, the question is, does module X require module Y? It's a two-way street. Does module X require module Y? And if we look in the module descriptor, for module X, it says requires Y. Then we check the bottom line, which basically says, does module Y export Q to module X? And in this case, we did the simplest one. We did module Y exports Q. And since we did not put a module destination there, it exports to everyone. So in this particular case, I don't know why I drew a red arrow, the answer is yes, because we have both the requires and the author said you can get it. Okay, so you need that. So that's the heart of access checking, and that's the heart of the module system. Okay? Whoops, I think we just did 2. So recap a bit, strong encapsulation, a module requires other modules, and the fine-grained control that we give you for, as the author for access, is a trade-off. We could have had you list all the classes that you wanted people to see. We could have had you just export modules. So we did a trade-off between giving you as much fine-grained control as we could and giving you the performance you want. Because you do know what access control lists mean, right? One's got to walk them, right? So what we did was we gave you the ability to export from a specific package to everybody or to a specific set of modules. And the key here, because we're built into the Java runtime, is that accessibility is enforced by the static compiler Java-C and at runtime. So it's enforced if you use the bytecodes, if you use reflection. It's the same accessibility check across the board. So you get early warnings when it fails. So I gave an example of a runtime error that my friend Harold extended. It says exception in thread main, Java lang illegal access exception, so that the access exception you would expect to happen. And we added the details to let you know what's going on. Class P.C in module X cannot access class Q.D in module Y because module Y does not export Q to module X. So if the export were missing, the goal of the error message, because VMs try to be invisible except where it could be helpful. This is a case where we thought it could be helpful to say, guess what, try exporting, okay? So, and the compiler will do the same thing, which is your early warning. So what we've been talking about is the module system. So there's two things. There's a module system, and then there's the Java runtime libraries, which have been modularized, okay? So the core base module, we call java.base, okay? And it's got things in it that you would expect. So we are all a lot happier when we agree on Java lang object, Java lang class, Java lang string. It's pretty messy when we don't. And this is an excerpt from its module info, okay? It's all open source. So we've modularized the JDK using the module mechanism. And if you look at the module info, you'll see java.base exports Java lang, Java IO, Java net, Java util. There's a bunch of others. This is just an excerpt. I put these in the middle box, which is blue, which shows these are the exported packages. I also put a couple examples of packages that are not exported, that are intended for internal use. Examples include sun.com.crypto.provider, sun.securityprovider, things like that. So we call these concealed packages. So every package is concealed unless it's explicitly exported, so the author gets to choose what is exported, okay? And that means that the public classes in those packages are not accessible outside of the java.base module. So let's write our own simple module. I did a hello world example. It's really stupid. I mean, it's trivial. You don't need to modularize hello world. In fact, a key message here is you don't have to modularize any application. It is totally opt-in, okay? Modules can be a little scary. I mean, module systems, and if you have a really complicated project like we did to modularize, it can take time. There are benefits, which is why people do it, but it's totally opt-in. You do not have to modularize any applications. You will, however, be using modules underneath because the JRE is now modularized. So here's an example of an application that you wanted to modularize. To make this a little tiny bit more complicated, let's pretend we have a fancy printer package, right? Or otherwise, what was the point, right? We have a little printer package that we want to export, and we have a little My Hello World that is a little built-in test, okay? So what did you need to do? You wrote the source. I didn't put it up here. I figured most of you could do Hello World in your sleep. I put up here an example of what your module info might look like. So we made up a module name, hello.world, to be creative, and we exported the com.hello.print package. Could have named it anything you like, and it requires java.base. So all it needed was java.base, okay? So we put that in there, and there is an arrow from hello world saying it requires java.base, and an arrow from java.base saying I'm exporting the packages in the blue box to everybody, and therefore to this guy. There's a green arrow I put on here, and it looked really dumb, so I took it off, because I tend to add complexity. But obviously, you are exporting com.hello.print package. So tell me later if I should improve the slides. So how do I use this? So compile time, Java C minus D mods. I probably should have picked a better name. That is just the name of the destination directory. Okay, there's nothing meaningful about the fact that it says mods, okay? Minus source path, you're used to these flags. I'm going to compile module info.java, which is at the top level in that source path, and I'm going to compile my source, okay? So Java C, in this case, nothing different except I had to compile my module info, and then I ran it, and you'll notice a new argument there. So Java minus module path, mods, that's just a directory name, and then com.hello.myhello-world, and got it, it printed hello, and it probably should have printed hello world, but anyway, I'll go fix that bug later. So the point here is a module is not just a set of packages, okay? A module is a contract. It's a set of packages that depend on packages exported from other modules and explicit set of packages it exports. That's part of your contract, right? You have APIs, you have your module contract. And that's how we get reliable dependencies. So you notice on that second command line, there's something new called a module path. What is a module path? Well, it's a path containing directories that contain modules. No surprise. Modules can be exploded directories, they can be modular jars, and there's some other formats. And so at runtime, we search the module path, and we search in the system image, the runtime image. In a fully modular application, there would only be a module path, but obviously we support mixed module and class path, okay? So the question comes up, well, you just told me all the problems with class path. Why did you invent something new that's going to have all the same problems, right? Well, we think it's a little bit better. So why is a module path better than a class path? So we mentioned a couple of the problems with class path. One is you can get in trouble when you have that old and new, multiple class path elements contain the same package. A class path is searched linearly. Remember, we walked through every time a new class is requested. So we've done a couple things to make this better. A module path forms a partition of packages, so no package can be in more than one runtime module. So you don't get into that conflict case. Modules perform a directed search. So once the runtime finds a module, and I'll tell you later how it finds it right away, it remembers its packages, and you never have to search for those packages again. So you can basically say, package Q, I know where that is. Okay, go get class out of that directly. And class loading becomes order of 1 instead of order of n. And since some of us have spent years trying to speed up class loading, we're delighted with this change. Where are the versions? This has been a long struggle. Modules can be versioned, but the dependencies, the requires, are not versioned. So we decided not to get into that for several reasons. One of those is that every build tool vendor does this slightly differently. And they found mechanisms that they're really good. I highly respect them. They handle versioning differently. And so no one would be happy if we picked, we'll go this way. The bigger reason though, which is really not that, is that when you take a class path, your build tool is doing the best it can given what we gave it, okay? It basically says, if you take the picture, hello.world depends on X, depends on Y, Y depends on lib, X depends on lib, but they need different versions. What is it really doing? Well, all we gave it the ability to do with class path was to pick one of those and have it found first, right? Right? It really isn't giving you version 1 and version 2 found by X and Y, because at runtime, a class loader pair is unique. Right? You give me the name of your class, like when you call load class, find class, resolve class, define class, which we didn't change the APIs, as a class loader, there's only one answer, right? And there's still only one answer. So in order to so we can't solve that problem this way. For folks who need to write containers, frameworks, who do more sophisticated things, there are ways to do it like there are ways today. You still need to use class loader isolation, right? So for a given class loader, you can actually find lib version 1, and a different class loader can find lib version 2, and you make sure those types never overlap, okay? So nobody in a class loader that's delegating to you will ever find, when they call foo.method and they pass a Java-lang string, it better be the same Java-lang string, that the caller and the callee agree on that. Or you'll see that class cast exception, can't cast foo to foo, where you're like, what are they talking about? Can't they spell? It looks right to me. Well, we enforce that. That's part of what I do for a living. You really don't want your string and their string, because they're different types. The type safety is important. So, but if you write a container application, go look up layers, L-A-Y-E-R-S. So we have a mechanism which is more sophisticated. If you need to explicitly do this, you need to still do this explicitly. So back to the reliable configuration. We create a module graph. So we take the requires, we start with a root set of modules, and we walk the transitive closure of the dependencies, okay? And that creates a graph. And this is probably the world's simplest graph, which basically says, hello world requires java.base. And we do this at compile time and runtime. We ensure at both times that there's no missing dependencies, no cyclic dependencies, and if any packages exist in more than one resolved module, which we call a split package, we fail. So we'll catch this at compile time if you compile together or you're compiling with your library. We'll catch this at runtime at the beginning of time, because we actually create the module graph up front. We think this complements build tools like Maven. Those are great tools for dependency handling. We highly respect them. They'll find and download the jars you want. They'll fail if there's missing dependencies. But we think we've augmented that by checking for missing dependencies at runtime and for checking for split packages so you don't have conflicts. So we think what we're doing is adding additional protections and then early warnings. So to sum it up, remember the 3 questions. Is anything missing? Are there any conflicts? Is it safe to change an internal API? So now we can answer these all ahead of time. So the goal is fewer in-the-field surprises, okay? Runtime surprises is part of what I give you and I try to avoid, okay? You do not want the VM to tell you, no class def found, or any other runtime surprise. You want to know these errors up front at build time. So we believe that with modules, we can catch a lot of these up front. We can ensure that internal APIs remain internal, so we and you can safely change them more quickly. And that the things that you run at build time, at test time, are the same things you're running at production time. So I borrowed this slide from Alex Buckley and Brian Getz, whose shoulders I'm standing on. And I really like it because it gives you a model that a module system is a seat belt, not a jetpack. So the goal here is prevention of problems. So you don't have bad things accidentally happening to you, so you can drive faster with confidence. So that whole section was about what is the module system. The next piece is about we modularize the JDK. So as somebody called it, the standard libraries of Java. So we built something called a system image. So in JDK 8, you have a JRE and you have a JK. You have rt.jar, you've got tools.jar, you've got a couple of other jars. Those jar files don't exist anymore, okay? We hope you don't depend on them. If you run on other vendors' Javas, you probably can't, because they don't exist in some of the others already. In Java 9, the runtime libraries are modules, and we build a standard runtime image that contains the java.se modules. We built something called a linker, a Java linker, and it does not produce executable applications in general. It produces Java runtime images, which are directory structures. What we do is we take a set of root modules, we compute the transitive closure of the dependencies, and we output a modular runtime image. So that's the same, what we call module resolution. We talked about running at compile time and runtime. We do the same thing at link time. and we create a runtime image. So we take modular jars, exploded JMod formats. The reason we added a JMod format, so jar files are really good for deployment. They're not the fastest thing for runtime, for reading. So we have something that actually makes it faster to read. We create our runtime image. Now you can also create your own custom runtime image if you want to. And if your image is a main class, we can make you a little launcher executable. So this little example shows you jar minus create. It gives it a main class, and it gives it, then you run JLink with that same module path that you would see with Java C or Java. And it says output to image 2. The add modules in there is to make that part of your root set. So that's where we start the transitive closure from. So at that point in the image2 bin directory, you now have something, an executable called 2. So if you run image2 bin 2, it gives you the epoch information, okay? So you can create your own smaller custom images if you want to. So this is what java.sc looks like. It's not rt.jar anymore. This is a set of modules, and I put them in the slide because I think it's useful if you ever want to look at it. This is how we split up the JDK. So if you've ever read any of the OSGI books on how to modularize a large application, it says, you know, this is really hard when you have something that's complicated and teased together to tease things apart, particularly if this API here that had nothing to do with it depends on AWT desktop, really? Yeah. So some of this went into Java 8, some of the cleanup, as we tried to decouple things. It's not easy, we did it. So this is one of the reasons that it took us so long to deliver Jigsaw, because some of you were expecting it earlier. In addition to a Java module system, we modularized the JDK, with the key goal being minimal disruption in terms of our API set. So a couple APIs had to change, but very few. Another major thing we've spent a lot of time on is backward compatibility, trying to make sure that existing applications can continue to run with no or minimal changes, and forward migration. So to enable you guys, our customers, to easily migrate to modules incrementally without having to wait for others. So in Java 9, you're getting both a module system and a modularized JDK. Let me show you the slightly bigger picture. If you're used to using the JDK, I don't expect you to necessarily read this from the back of the room. I put this in the slides because in one of my later slides, I'll tell you when you might want to look it up, and it's just, URLs are so hard to find, I thought I'd just put it in the slides for you. So this includes things like the Corba, JTA, JaxWS, the EE annotations. It also includes the compiler. If you look in the middle, there's Java SC and the things it depends on below. This is a module graph. Sorry, I should have told you that to start with. If you'll notice, it's probably hard to tell the difference, but the lines to java.base, which look non-existent here, are really faint. And that's because you get that one for free. You get one module for free. So even though the hello world example said requires java.base, you get that whether you specify it or not, because duh, if you can live without Java-lang object, you know, tell me how. I can't even bootstrap without it. But I included this in case you need it. So it's just for reference. And the question is, one of the big questions people are asking is, how do I move to Java 9 and is this going to be hard? And do I have to modularize my application? And if I do I have to wait for all the libraries underneath me to modularize? No and no. You do not have to modularize your application, and if you do, you do not have to wait for the libraries underneath you to modularize in the general case. And that's part of what we've worked really hard on. So let's walk through moving to Java 9. First thing to do, there's a link here to the early access binaries. They've been available for quite a while. We're still updating them. We're not quite out the door yet. And if you're like me, forget the reading the stuff. Just go try it, right? Right? Read this first? You've got to be kidding. Try this first, right? So go try it, run it with your current class path and your current arguments, and give it a shot. And if it works, you're done. So happy? So our goal is to have as many people happy like that as possible. So any clean application that just depends on java.sc should just work. What if you got a no class def found error? Well, there's a new tool which you really want to look up. It's called JDeps, Java Dependencies. And there's a run JDeps -s, and it'll tell you what you depend on. So the reason I gave you that EE graph was in case you've been depending on any of those packages. We have part of what I do for a living is add command line parameters to give you workarounds. So we've added a flag, -- add modules equals, so that you can add a non-java.se module to your module graph, and now you're running. Okay, now you're up and going. So that's why I gave you that graph in case you're currently depending on any of those. More rarely, you might need to change your sources. So this is where I should put up the picture of the guy crying. So I've talked about enabling strong encapsulation as a key goal. So one of the reasons for this is that with stronger encapsulation, we can evolve the JDK faster. And if you adopt modules for your own library or application, it enables you to evolve faster. One of the downsides there is that this warning, this is actually a JDK 1.1 doc. Okay, so it's been there longer than I've worked on Java. And it basically says sun.star packages are unsupported and we don't recommend you use them. And the challenging part is that we are actually now going to do something about that. So how many of you here ignore compiler warnings? Come on, fess up. Really? Warning? Error? Oh, darn. Warning? Who cares, right? So our goal has been to make this incremental, make it staggered. We have this concept of deprecation. We tell you now, we give you heads up, we give you workarounds with flags. We have a wiki page that says this is the unsupported API, this is the recommended API, please do this, we're giving you time. So yeah, we're doing everything we can to make it possible, and the message is we really are going to take these away. So please change. If the workarounds we've given you aren't good enough, let us know. We're listening, we care. Please work with us on this. So I'm going to highlight a few of the incompatible changes. I hope you're not using them. If you are, we fully understand that you use things because you couldn't find any other way to do it, right? So you're trying to get your job done as fast as you can. So let us know if there isn't a better way. There's classes have been removed from sun.misc. We think we've provided some better ones. I mentioned var handles earlier. So if you've been doing some of the unsafe, or the sun.misc unsafe atomic type stuff, you now have a really cool way to do it. I'm just saying, really cool. So these are currently there. These are still accessible, but we're deprecating them, and that means when we see the deprecation warning, we really are going to get rid of them. So please move off of them. Some packages have been encapsulated. You'll notice the word security. You'll notice the word sun. You'll notice the word internal in a lot of them. That means that they are not exported by default. And yes, I work in the VM, and part of what we did was provide you with some command line flags that gives you a workaround, but the intention is please stop using them. So we're trying to give you time to migrate. I mentioned that rt.jar and tools.jar are gone, and we've been surprised by the number of people who actually were looking at the disk layout. Please don't count on the new disk layout. We're planning to evolve it. If there's things you need, let us know, okay? Because we want to provide APIs that give you all the information you need. Class loader assumptions, xboot class+/p is gone. And for those who care that the application class loader is a URL class loader, it is not anymore, okay? And most of you are like, why would I care? You don't even want to know what people are doing. How to prepare. I mentioned JDEPs. That's your friend. -JDK internals will tell you dependencies you have on things that are not externally exported. So these are the things you want to highlight on. And when you look at that wiki page for JDEPs, it gives you the whole chart of if you're using this is the recommended solution. If you don't find something there, let us know. If you find that the thing there does half the job you needed and you can't figure out a way around it, we may be able to help you. We're constantly evolving the platform. We're trying to make it better and better. Go read Project Jigsaw. There's a whole bunch of modularity JEPs, so I tried to highlight them here because the list is so long, it's easier to have a list in one place. The 261 JEP is the module system, and that's where you get the concept of access and requires and exports and a whole bunch of details I didn't go into, which many people won't ever need to know, but if you're doing anything fancy, you will. And it's got a lot of the concepts, and it explains them much better than I did. The encapsulate most internal APIs is the one that you say, oh really, did you really have to tell me not to use that? That's where to go for that. The Java linker is there. What else is there? Some useful, helpful Java and Java C module flags. Hyphen, add modules, add exports, add reads, add opens. If it starts with hyphen in Java, that means it's new, because that's our new syntax approach. It should be the same flags for Java, Java C, and the Java linker. So go try those. So frankly, I want to apologize a bit because some of the changes we've made are disruptive, and we really try to make it so you don't have to change your code. We had to tighten some of these. Some of them are security holes, and it's scary to see something on Stack Overflow that says, you won't let me change the security manager. And you're like, no, actually, we don't think that's a bug. We really don't. The person who's running this actually kind of thought they wanted to run a security manager, and they didn't want this framework to go poke about and change it on them. So for security reasons, we had to do this for some of them. We actually have worked very hard to support backward compatibility. We can't always do that, especially for folks who are using set accessible and quietly overwriting your private fields, yours and mine. But some of the things we have done to support backward compatibility, which we've worked very hard on, this is the big one. We created something called the Unnamed Module. So the question was, how could a current application run over top of our modules, be part of the module system, and you don't have to make any changes, right? Because that's a primary goal of this exercise. You don't have to make any changes. What did we do? So we talked about building a module graph, right? Which puts follows the requires and makes a graph, transitive closure of dependencies. So all the code on the class path gets put into one big module called the Unnamed Module. There's actually an unnamed module for every class loader, for those of you who want something more complicated. It requires everything, it exports everything, it opens everything, and that provides maximum compatibility for class path behavior. So that's how you can continue to just happily use the class path that all works. This allows us as the Java library providers to modularize. This also allows other libraries and frameworks to incrementally modularize without having to change applications. So that was key, was that there's a migration path. You can change your library, you can change your framework, and the applications don't need to know. Now I'm going to talk about how to move your code to modules so you can get some of the benefits. So the first thing you want to do is read that JEP 261 I mentioned, and read the state of the module system. It actually explains things far better than I did. So then the next thing you do is you create your module descriptor. Well, actually, we wanted to make that easier. So JDEPs --gen -module -info and source blah, blah, blah. Use the Java 9 JDEPs for this. There is a Java 8 one, but the Java 9 one obviously does more. And that will create a starter module descriptor for you. It may be sufficient. You may be done. So one of the key things we wanted to do was enable you to migrate your application or your library without having this, we got to stagger and wait for all the libraries you depend on to modularize first, because that's a many-year exercise, and some of them are binaries that are no longer supported, which you almost don't want to admit to the class file versions you're using, right? Someday, I don't want to support 1.1 class file versions. But anyway, for now, we support everything. That's the royal we, right? Anyway, do you have to wait for the libraries to modularize? And the answer is no, you don't. So we have a mechanism that lets you modularize your application or your library without depending on the jars underneath you. So here's an example. Migrating from the top down, you have my app, and you split it into my app and my lib, and you want to export my lib, for instance, or you don't, but you wanted to split it into these pieces. On the very bottom, you see the SE modules that you depend on, so java.base, java.logging, java.xml, java.sql, etc. They're already modules. You know how to deal with those. In the middle, we have a sample of jar files. What are you going to do with those? Well, we talked, and we finally decided that we would do a little magic for you. We're going to pretend these libraries could be turned into modules, and we're going to say, write your module info. Okay, so my app requires my lib. That's your stuff. You know all about it. You ran JDEPs, so you know you just need Java.base, Java.SQL. And then what we're going to do is we are going to infer module names for you from the jar files. We are going to turn those jars into automatic modules. We're going to infer a name so that you can require them. And in this case, Jackson.databind actually reflects back on your code. So we are going to open for reflection, but that's sort of an advanced piece. So what is an automatic module? They're real modules. They play in the module system. You don't have to make changes to someone else's jar file. We infer a module descriptor, a module name which is derived from a jar file name. We export all its packages, and it requires all of their modules. So this does not always work. If there's cyclic dependencies or split packages, we can't do this automatically. So in that case, you got to talk to the library developer. But where we can, we'll do this for you automatically. And you can modularize your application without waiting for the step underneath you. A couple other things we did to make migration easier. There's something called multi-release jars. And they allow you to distribute a single jar file that works with multiple Java releases. So you can have the default classes that are included, and then you can do a Java release specific version with this string syntax that says for release 9, go use this one instead. So it allows you to have sort of 90% overlap, or whatever overlap makes sense for you, and have a couple of files that are version specific. Another thing we did was we allow you to compile for older platform versions. One of the things that already exists with Java C, there's the -source and -target. So -source is which version of the Java language the compiler accepts, and -target is which version of the class file we generate. The new one is called --release, and in addition to setting the source and target, it also only uses APIs designed for that specific release and below, okay? So, because I have a little bit of time left, I'm going to give you some highlights of post-Java 9, because we're working on some really fun things. We thought we would love you to come play with us. So highlights. Project Panama, we're improving the Java to native interconnects. So both ease of use and performance improvements for Java access to native functions and data. Amber, which is some productivity-oriented Java language features. Valhalla, which is user-defined extended primitives. And JEP 11, I should have put JEP there, is incubator modules. So you notice that we had added G1, or garbage first, as an experimental garbage collector in 8. It's for JVM features, we've had a way to do that. It is now the default garbage collector. In Java 9, we've added AOT, ahead of time compilation, JAOTC. It's experimental. Feel free to play with it. We haven't had a good way to do that with libraries. And we've also had, for library evolution, there's been very much of an expert group involvement for each library. We'll continue to have that. We also want more general involvement. We want to invite this to be more open for feedback from more people. So we believe if we can do incubator modules, don't count on them for production. You know the APIs are going to change. But if you want to get in on the early days of experimenting, of giving us feedback, we'd like to hear from you. It'll allow us to shake it out and make it better fit your needs. So this is a way to have the broader community involved sooner, and it allows us to get it to you a little sooner. So feedback welcome. A little more on Project Panama. So ease of use. If you want to provide a Java API to a native library, whether it's an existing standard library, C library, whether it's existing GPU library, whether it's something new that you've provided, this is all futures, this is all coming. Some of it's in prototype today, and if you get on the Panama project, you can play with, there's a JExtract tool that will take an interface definition from C, and we're planning to do C++ include files, and generate you a Java interface. So and the next piece is there's a binder that binds the native library as a Java API, and potentially people might want to standardize these. So the point is you can create a Java interface to a native library, and then the library user just writes normal Java code. Okay, so we think that will help with both ease of use and with performance. We're also optimizing the Java calls to native and the Java access to native data. This is not an evolution of JNI, it's something completely new. It's not completely new, it's actually an evolution of JNR and FFI foreign function interface. So we're working with the community to do this. Please join. We think it's cool. We hope you'll like it. Project Panama also has a vector API, which is designed to expose data parallel operations through a cross-platform API. That's also been done jointly with the community. We're designing an API which is type safe. It's an API to use vector type, which are parameterized by the element type and the size. So like I've got 8 ints or 4 longs or whatever. So you can handle 128, 256, 512-bit values, byte values. So one of the goals here is, so right now we actually vectorize operations like array copy and array.equals under the covers. We auto-vectorize. We also transform some scalar operations into superword operations for counted loops. But we want you to be able to say, hey, I'd like this code to actually take advantage of things like AVX instructions when they exist. And one of the benefits of being a language with a JIT is we know what exists on the hardware. We know precisely what exists on the hardware, and we will use the fastest instruction set that's there. So Project Amber, just a couple highlights. I sat next to somebody yesterday who was actually saying, yeah, but what a pain. I always have to type, I have to declare my local variables with a type. And I thought, oh, come to my talk. So we are going to be adding extended type inference to declarations of local variables with initializers. So if var list equals new array list of string, you can infer that list is an array list of string. So for those of you who find it too much to type and too much boilerplate, we're listening, we're working on it. And that's just a highlight. There's a whole bunch of others that I don't have off the top of my head. So go look at Amber, and if there's other things you want, it's a good time to ask. Enhanced enums allow generic enums, type variables in enums. There's some cleanups from Project Lambda to improve usability of lambdas and method references. So things like allowing underscores for unnamed, unused parameters. If there's other things you want, this is a good time to ask. Nestmates, I'm involved in this one, so I think it's pretty exciting. So we talked about class package module. Well, between a class and a package, we're adding the concept of a nest. It's not totally new. If you've used nested classes, you've actually kind of played with the concept because you take a single source file and it has multiple artifacts, right? Because it makes multiple class files today. That's not the only way to make multiple class files today, and there will be more in future. So the theory is the classes in a nest usually derive from the same source file. So there's an expectation that they should be able to access private members in the nest, right? It's the same source file. I wrote it. I'm the author. I have control. I want that. So right now, the Java language allows you to do this, and the JVM doesn't. Yeah, sometimes we don't talk to each other as well as we should. So it's done through bridges or trampolines. So we believe if we can actually put the nest concept into a class file safely, that we can actually give you that access without exposing that access in ways we don't want to. So this should help us clean up a bit of nested classes. It should also help us build sealed classes, which you specify who can extend, so they're not fully final, but you can only be extended by certain other classes, and build a safe alternative to unsafe defined anonymous class. So if you're interested in that, keep us posted and keep listening, and go look at lookup.define class, because that's where we're doing the first step on alternatives to unsafe defined anonymous class in 9. Valhalla, this enables functional style computation with pure data to optimize parallel computation. So one of the goals is we have 8 primitives today. And for those of you who've ever wanted your unsigned int or your complex or your vector or your tuple, this will allow you to do user extended types, and of course we'll be adding some of those ourselves. The goal is to improve performance for modern hardware where the CPU is getting faster than the memory access is getting faster. Brian Getz has a couple of fun videos from the Language Summit last summer, and the motto here is codes like a class works like an int, so you get the coding and the type safety, and you get close to int performance wherever we can. So I'm putting in a little plug for this because I'm working on it at the moment, and value types is a piece of that. The Valhalla has the concept of these values. It has the concept of language changes for them and libraries change to use them. Our first step is the VM piece, which is value types, which are immutable identity list types This allows us to do JIT optimizations. It allows off-heap allocation, so registers stack other memory, which reduces your GC overhead. It allows us to flatten contained values and do faster access, because that will reduce your indirection and reduce your cache misses. So we're working on an early adopters experimental version. So this is experimental. This is if you're way ahead of the pack and you're dying to use this and you want to play. We're making a very early version, which you use method handles to access, because we're not making any language changes yet, because the design of that is still evolving. But if you want to play, please contact us. So you can go read the proposal, give us feedback, and play with us. So, summary, please get involved. Check out the Open JDK projects. Help us improve Java. Any questions? Oh, somebody's got a mic. Oh, thanks. That was all self-explanatory? There's a question in the back.
Give me the mic for the recording. Sorry to be the most inconvenient place to get a question. I work on Clojure, and we're working through a bunch of issues on related to Java 9. There are some issues, but they're mostly our fault, not yours. One question I had, though, is about reflection access for modules and where the dividing line is between sort of what modules allow you to do reflectively, like walk class hierarchies, versus maybe I don't expect it to allow me to reflectively invoke things that I don't have access to, but I think I'm not sure exactly where the dividing line is on what I'm allowed to do.
Oh, that's a very good question. So yes, I've been. Oh, what's Toby's last name? Who just gave a good
Crawley,
talk?
Yeah.
At Red
Toby
Hat.
Crawley, yeah.
Yeah. You're not Toby, are you?
No.
So I watched the talk.
But I've been working with Toby on that.
Oh, good.
Stuff,
I watched the talk. It was a great talk. I took notes. I don't have them all on the top of my head, so I'm going to apologize for that. My husband works in Clojure, so let's just say at home we really care about that. Actually, we care. The JVM is a multi-language VM, and we care deeply about Clojure and Scala and JRuby and other languages. I don't totally know the answer to your question. I know that you're not supposed to have access in terms of methods and fields and set accessible unless you do an add opens. I don't know of restrictions to walking hierarchies, but you've obviously run into some, or you wouldn't be asking me that question.
No, we're just starting to work on some of the changes for reflective access through class loaders.
Let me write that one down, because I don't know of any places. We do the access checks, so I don't know of any places that were called that would say you can't walk through a hierarchy, or that you can't see visibility of a class. So I don't know off the top of my head any place we would stop you, but. If I'm wrong, my name's on the slides.
Yeah,
We'd really like to hear from you. Seriously,
Yeah.
if I'm wrong, please come ask us, and we'll work with you to make sure there's a way to do that.
Okay. The other thing that I have seen is that we use in the Clojure REPL, we use SunMISC signal for catching Control-C interrupts specifically. And I know that's one of the Sun classes, and I would be happy to not do that if I knew of any other way to do that. So I don't think there's any alternative. I know there are some other uses of signal that are maybe not good things to do, but that one I'm not sure how to get around doing.
Did you look on the JDEP's page?
I did, and I don't think that there's any workaround for it that I've seen anywhere, so I was just curious.
So that's specifically you want to catch Control-C?
Yeah.
Well, look at that.
It's such a simple thing.
Oh no, I do signal handling too. It's never simple. Let me look at that. Any other questions? Well, in that case, thank you very much.